If we just talk generally at the start about the total amount of water that's allocated, that's not per individual, that's across a catchment, for instance, in surface water, or across a groundwater body like the Canterbury Plains. We use computer models to say, if you took this amount of water out of the groundwater, for instance, what impact would that have on our lowland streams? So that's the way that we say the total amount that can be taken in a year is based on what impact it has on our lowland streams. So we start looking at how low can the stream go in order to support the ecological life in the stream, and then also how much could we take, so that, because we also don't want what we call flatline a river, which is when the flow stays just the same all year round. If we took all of the flow out, it would just be even the whole year, and then there'd be no floods. And floods are good for rivers. They clean the rivers out, they help it ecologically. So if I was to draw that with time, if you have, so here's time, and this is flow of the river, and the river goes up and down with time. And what we're trying to work out is how much of this water can be allocated. Now, we don't want to go too low, so we might say we're not going to take it below this level, for instance, because we know that once we go below that level, it starts affecting fish and other things that are living in the river. At the same time, we've got to think about how much, the height essentially. Will we take all of the water between these two? Now, if we did that, then the river would be a flat line the whole way, and that's bad for the stream. So what we actually do is we don't put it up there, we might put it about here. So what we're saying is that amount of water is available at a certain time out of a stream.